got loyalty, got royalty inside my DNA.
But yeah, hi everyone, welcome. We have definitely quorum. This is PL Talk. It is a weekly live stream started by Hongi and me accidentally last year. Hongi took me up on like a half serious offer to stream once, and then people showed up to our great shock. And then it was really fun. And so we were like, all right, we'll keep streaming as long as, you know, people keep coming. And we didn't really put very much work into inviting people. We're just like, all right, people can be guests. And then we keep having enough guests. So sometimes it escalates. We get like, you know, more and more guests, and we're like, wow, I guess we have to keep doing this. But it's been good. The philosophy is we want to make programming languages and tools accessible. And Jordan, who was actually a student in my group when I was a professor at CMU, knows this was very much, well, back then we were trying to make types accessible. Now we're trying to make everything accessible, but Jordan is making types accessible. Yeah, I'm Jean. I'm the co-host. I'm the founder and CEO of a company called Akita Software, which we were just bantering about. And I was previously a professor. And that is how I met Jordan, one of our guests today. So Jordan was a junior. I started at CMU at the beginning of his junior year, and he wanted to work with one of the cool older professors. And his friend Ben Lichtman, who was a guest a few weeks ago, said, no, Jordan, you should work with one of the new professors because they will have a lot of work they need to do because they're at the beginning of a lot of work. And so that turned out to be true. Jordan and I did a lot of work together. And now he's at Facebook with Mike doing more work. And so today they'll talk to us about all the work they're doing with the static type checker for Facebook, which I think is like, so I tweeted about this, but like Facebook has been doing the most crazy stuff when it comes to tooling for dynamically typed languages, because yeah, like first they build this compiler for PHP, and I was like, man, this is nuts. Like why would you ever do this? Then they built like a language on top of PHP with all these annotations, and they statically check it. And I'm like, whoa. And then like by then I think like, you know, statically checking dynamically typed languages had become mainstream, but still what Facebook is doing with Flow is like not normal things that people like thought that they would be using JavaScript to do. And so Facebook has a JIT for JavaScript. Facebook has a type checker for JavaScript. So today, hopefully, Mike and Jordan will talk about all this. But first, I'll let Hongi introduce himself, and then Jordan and Mike can take it away.
Sure. Hey, I'm Hongi. I'm the other co-host. I represent the every programmer perspective. And I am currently a security engineer at Figma. And I'm also curious to hear a little bit about the whole idea of making types accessible, which I suspect is very relevant to this talk. So I imagine we can work that into the intro for Flow.
And cool. So Jordan and Mike, yeah, if you could just introduce yourselves. We already told everyone we already told Jordan and Mike you're here for the demo. So it'll be short.
Yeah, so I'm Mike. I'm a researcher at Facebook Seattle. Been here for about 2.5 years. Before that, I was at Indiana University as a grad student. I'm pretty closely connected with a couple of PL Talk alums. My advisor was Jeremy Seek, and also worked pretty closely with Sam Tobin-Hoekseth. Yeah, I'm excited to talk about some of the stuff that we're doing with Flow.
Also for those who remember, Jeremy Seek also came on PL Talk kind of halfway. We were doing a session on gradual types, and we were like, let's DM Jeremy and see if he can come. And then he showed up halfway through. It was really cool.
That's epic. I'm Jordan. I'm a software engineer at Facebook. I was based in New York, but now I'm based in Florida, and I'm very excited about that. Like Jean said, I was your student at CMU doing research on, we were verifying the boundary basically between applications and the database for privacy policies, and then within the application itself as well. And it was a lot of fun.
And yeah, it was with Ranjit, who demoed the fruits of Jordan's labor years after, because Jordan and I hit a big obstacle like on the last day of his thesis. And then we're like, oh no. And it became like a whole other like master's thesis. It became this whole other PhD project that someone did. And then Ranjit finally demoed it when he came on PL Talk.
Yeah, I just wanted to graduate, you know. I was a senior, I was deep in senior, and I was like, wow, this is a big problem.
I have 2 hours left to solve it. And I was like, don't worry, this is like a years long problem.
Awesome. Well, so I can get started with just talking a little bit about like what flow is and why, why it exists. I have a little bit of a motivating example, hopefully, that I can show. Oh no. Jordan, you want to talk for a second while I fix the
Yeah, I got you.
unsurprising issue that I just ran into with my computer?
Yeah, so let's so Gene, you brought up the crazy things that Facebook is doing with gradual types, and I think the crazy thing really lies in the architecture of these type checkers. And it's not like a program that you run once and it type checks. It's a server that lives for your entire development process, and you send it incremental updates to the code that you're
Just to
changing.
interrupt to let you know, I have to quit and rejoin in order to share my screen on Zoom.
Okay,
No,
cool. I'll
sorry.
see you shortly. No worries. I think, yeah, Jordan has seemed to pick a juicy topic. So,
Yeah, juicy one.
So Jordan, do you want to just explain like what flow is, why it's different than TypeScript, why you didn't merge, and then, yeah.
Yeah, so Flow is also a static type checker for JavaScript, like TypeScript. The primary difference, if I had to pick one, is that we don't have an associated runtime. We don't have a compilation phase. We just strip the types, that's it. So we're JavaScript with types sprinkled on top. And to run the JavaScript, all you do is remove the type annotations. We have very different goals in TypeScript, I would say. Facebook, for the most part, or sorry, Flow for the most part has had to keep up with Facebook's growth, which is ridiculous. And the code base is massive. And it's at the point where, I mean, we have like several million lines of code in our code base, and a type checker that can't handle that entire code base all at once just wouldn't be sufficient for the like Facebook repo. In addition to like all those lines, it's not a well-structured project. You can import any file or almost any file from any other file. And there are some file cycles that are bigger than significant open source projects, just the amount of files in the cycle. So it's like these crazy scaling problems that we have to deal with. That's like one of the primary motivations for Flow as a tool separate from TypeScript.
Well, I just have a quick question. So is it true that if you tried to run TypeScript on the files of your size, it would just like, what, does it time out, or does it just take too long?
I don't know that we can actually test that, but I think it would, someone did research into this at some point, and it would take too long and would require actual structure to our code base that people aren't willing to do. Like for example, Google does have a very large code base also, and they use TypeScript, but the way that they do it is they have like each sub project is its own, like has its package.json, and it packages its types into an interface that can be shared elsewhere. We don't have any of those luxuries. Ours is, Flow reads the entire code base, and if you make a change, it could literally affect any other file in the code base. So it has to track the entire dependency graph and follow the changes all the way through.
I see.
Oh, okay. So you basically have like a mono JavaScript repo. Basically, everything is in there. You're not packaging up separately the way that Google is.
Exactly.
Correct. Yeah. And it's ridiculously massive. And it gets bigger every day.
And it's really used as a mono repo too. Like it's not accidentally a mono repo. Like the fact that things can be imported and used from anywhere in the code base is really a use feature, and changing it would probably be unrealistic in a reasonable amount of time, given the speed at which Facebook moves and the way that it's growing.
Cool. And I know we're trying to get to demos, but there are a couple of audience questions already. Someone said, I thought TypeScript was a separate language. Can you just run it on JavaScript? And somebody else said, doesn't TypeScript have local type inference? Why do you need to run it on the whole thing?
I think TypeScript has diverged more from JavaScript than Flow has. I think TypeScript, my understanding, and I don't want to speak for the TypeScript developers since that's not who we are, but my understanding has been that TypeScript was sort of designed from the ground up to be a very JavaScript-like language with a significant overlap, but was never intended to be JavaScript. And people were, I think, expected to write JavaScript developers were probably going to write new programs in TypeScript, or put the effort into migrating their programs from JavaScript to TypeScript. Flow, on the other hand, so this is a place where like the story for what Flow is has evolved over time as the JavaScript, as the Facebook code base has evolved. But originally, like Flow came into existence when Facebook already had one of the largest JavaScript code bases in the world, maybe the largest. And it was already there. Like it wasn't tractable to say like, all right, let's migrate the whole thing over. So I think a difference in intent at the beginning, especially between Flow and TypeScript, is Flow was originally going to be giving type information and checking to existing like baseline JavaScript programs. And in fact, the example that I can show in a second sort of shows that in a very small way. Whereas TypeScript, I believe TypeScript was always designed that you could write new programs in it. It wasn't intended for existing code bases unless developers wanted to put in the effort to transition. And then for the local type inference, yeah, TypeScript does have local type inference, but I think it's, Jordan, you can correct me if I'm wrong about this, but I think it's like the scale issues that we're talking about are really like merging the interfaces of different modules and figuring out like how, we can check internally the modules in isolation, but building the relationships between them, even if we have checked the modules in isolation, is a big problem when you're at the scale of something like Facebook.
Yeah, and also importantly, if you have all the module signatures already in hand, then you can always check the file that you're currently working on. But if you change your file's module signature, then that's where the real big problem comes into, because then you have to know how that affects files downstream, if it affects their exports as well. And you have to track all those changes all the way down to like the very leaf nodes where those changes stop propagating. I think also about I think TypeScript does actually have a very good incremental adoption approach. I'm pretty sure they have support for like JS doc comments, and they'll type check just based on that. I think that's like their very baseline. And I think there's like the non-strict version, which is easier to start converting to than the strict version. And then you start adding flags. So you have like basically like a well-typed Java or TypeScript code base. But at the beginning, when Flow and TypeScript were both very new, like it wasn't even there wasn't this like industry-wide mind share about the values of, I think, even typed JavaScript at the time. So it wasn't clear that any tool was the right tool for Facebook at the time. So someone happened to be building one that I think it was in like 2013 or 2014, which I think is also around the same time that TypeScript was being built. Or at least the first open source release was in 2014. So that means it was probably being worked on even sooner internally.
Cool. So yeah, this is the demo's already up. So let's dig in.
Cool. So yeah, and this kind of gets to like what I was saying about what Jordan was saying about the incremental adoption and like the existence of this big untyped JavaScript code base. So let's say that like we haven't gotten type checking yet. We've just been writing a JavaScript program. And I wrote my print greeting function that takes some person object, and I expect it to print, hello, my name is the name of the person. And I have my little internal helper function that takes the person and returns person.name. So given that like original function, maybe I'm a user of this, maybe I'm a client of this library, and I've made my object that represents me, and it has the first name field. Oh yeah.
The font size could be a little bit bigger.
Oh yeah. Let's
feedback.
How
cool.
is
Perfect.
that?
That looks very good.
Sweet. Okay, cool. So yeah, we have the print greeting function, tries to print out hello, my name is, and then my name. And I'll make the object representing me. And so in JavaScript, this is this line here just creates an object with two properties, the first name and the last name. And maybe because I didn't read the documents, maybe because I didn't read the falsehoods programmers believe about names, whatever reason, I just assumed that it'll have a first name and a last name field. And when I try and run this program, I'm going to get, hello, my name is undefined. and this is a particular feature of JavaScript that's always fun, is when you try and get a property that doesn't actually exist on an object, the way that name doesn't exist on Mike, you don't get an exception as you would in many other languages. You get an undefined value that can then be passed on elsewhere and cause all kinds of havoc. So if you imagine this is the state of Facebook's code base when Flow was first coming around, and of course you multiply this by a few, dozens of orders of magnitude in terms of code size, we don't want to have to transition, we don't want to have to add type annotations to this entire code base, and we don't want to have to translate it into another language. So instead, what Flow lets you do is simply turn on checking. So I've had a Flow server running in my VS Code in the background this whole time. And by putting the @flow, we're now going to start type checking. And even though there's no type annotations, Flow will detect that there's an error here, because when we try and get person.name, well, person.name is missing in the object literal that we've passed in. So even without adding any type annotations, Flow will start to provide type errors and user feedback. So like we can see that if we mouse over the getName function, we see its type. So that's great, that's progress. But of course, the place of this exception that this error is being raised isn't super useful if I'm the client. I'd have to dig deep into the implementation that I'm calling in order to figure out what the actual error was. And so Flow then let you incrementally add type annotations that it would treat as sources of truth instead of things that it had to infer. So now we can add the annotation that person really should take a name that is a field, a string field, and maybe it can take some other things as well. It can, maybe there can be other things in this object, which is what the ... signifies. But at least it has to have a name. And once we've done that, we can see that we get the expected error at the call site of print reading, telling us that this object we've passed in doesn't correspond to the specification we expect it to have. So that's kind of like the very short, it's kind of the same justification as any type checker, but the fact that Facebook was already this huge code base with no annotations meant that we really had to have an extremely powerful inference engine and have as little of a need for annotations as possible. But as Flow has evolved over time, annotations have become more common. And I think an interesting thing about Flow at Facebook that we'll get into is that Flow is a language that's really designed for pretty much a single code base. Like it's open source and we encourage people to use it, but our design is really based around the internal Facebook code base. And that means that as Flow evolves, it can trigger the internal code base to evolve, which can then allow Flow to change as well in ways that reflect that. So there's sort of a co-evolution between language and code base that I think is pretty unique, other than similar like what we've done with PHP and Hack. So I can hand over to Jordan now, who has, I think, some other demos that show the kinds of things that Flow is capable of. But this is like the high-level idea of why do we have Flow? What's it here for?
Cool. Mike, I was curious while we're switching, if you could talk a little bit about how you, because of like how it's tied, the design's tied with the code base, how you got it to adapt to like module resolution scaling issue that you were talking about with TypeScript.
So I think it's hard for me to answer that because I wasn't around for a lot of this. So some of this is kind of history, but I think the module resolution and like the scaling was really a core part of the design from the beginning. Like I think that was the other justification for building Flow was as its own thing, was we needed to be able to handle the scale and handle the size of the code base. I think so Jordan has some examples later on for how we've worked with the code base as it grew, because the original approach that we took for module resolution and type checking the code base didn't actually end up scaled to as large as the code base has eventually become. So a couple of years ago, we completely rebuilt how we do that work, and so maybe I can hint at that, and Jordan can show that example as we go farther in the talk. But the original system, I can't really speak to the design of before my time.
I'm also happy to go into the scaling performance aspect first, if that's what people are more interested in. The demo I was planning to show right now is like basic type system features, but if people are familiar with TypeScript, it probably will mostly be review.
I think I'm happy to jump into the demos. Not seeing too much feedback on that in the chat at the moment, but I think people came for the demos. We can chat with that later.
Yeah, people want scaling.
Oh, actually, they want scaling. Never mind. 4 votes.
Okay, cool. So let's do scaling first then.
Yeah, people are like, we know TypeScript. Cool. Well, if you don't know TypeScript, we want to foster a supportive environment. So please feel free to ask your questions in the chat still.
Okay, sorry, 1 second. Let me pull up the correct demo for this. So I'm going to do this in 2 parts, I guess. The first will be how the code evolved as we needed different things to scale, and then I'll show how the scaling actually worked.
Cool.
I might also have to rejoin the call to make this happen, though.
Oh
no! Zoom problems.
Yeah. All right. I'll be right back.
I think we both didn't. We probably both haven't used Zoom to screen share before on our work computers, since we have the Facebook specific screen sharing solution, of course, internally. So
yeah,
I think we were both confronted with you need to restart Zoom to give permission to screen share.
Yeah. Here's a quick question, I guess, while we're waiting. Someone was asking, like, what is that coverage 90% at the bottom of, I think it was your VS Code screen. Maybe you could talk a little bit about the tooling that you got an hour later.
That is a really good question, and that's something that I think we'll talk about. That's another one where we have some demos that we'll definitely get to. But the short of it is the coverage describes how much of the code is not dynamically typed, and it's sort of our solution for how do we reduce dynamism in a code base gradually. But yeah, we have a demo for that, but let's make sure that we get to.
Okay, so this code intentionally has a bug. There's a function that is intended to take null or a number and return a string indicating whether the value passed in was a number or not. This stuff all basically works is the same way that Mike's example worked. Flow's doing full inference on this file. It knows that based on the calls, the types here are going to be null or some number. But this doesn't explain the scaling stuff. Here's how we deal with module boundaries. So as soon as we export a function, let's just run flow. Yeah, so as soon as we, oh wait, I'm on the wrong version. So as soon as we export any function, we required, at the very beginning, we required annotations in all the input positions. And so the idea was that if we had all the input positions, then we can infer the output position if we traverse the entire code base in dependency order, and then we would be able to infer the types of all the exports. So if I put here that this is number or null, and run flow, we'll have no errors, and any file that depends on this will be able to figure out that this is a function from number or null to string. So then the next thing that we started to add in, well, taking a slight detour from scaling, this was another code base evolution thing. So this code still doesn't work as intended, despite there being no untyped things in the entire file. And the reason it doesn't work as intended is because, so here, if we just run this, keep in mind that our expected results would be that 3 is a number, so X is a number, X is not a number, X is a number. But if we run the code, then...
Jordan, question. Someone had a question in the audience about, aren't you applying flow to completely untyped code? So why are you writing types?
Yeah, I think that was kind of that was what we were willing to do at the very beginning in order to transition our code. It's not quite true that we didn't have any, that we weren't willing to add any types, but we were willing to add only types at module boundaries, and particularly specifically at inputs to modules. So that was when we started adopting Flow into the code base. We would incrementally take a module, add annotations to the inputs so that we can check it in this relatively scalable way, but not expect it to be on outputs from the module or on anything internal to the module.
It's also possible that, so Mike and I joined the team only 3 years ago. And so 6 years ago, the rules for exports might have been different. We might have started inferring any if there were no annotations, I don't know. But I know that there was I'm pretty sure Gabe, who left the team about 2 years ago, did do a big code mod push at the very beginning of Flow's life. So there must have been some annotations that were required in order to get Flow to not error on module boundaries. So back to the example, we said the expected output was that x is a number, x is not a number, and then x is a number, but 0 is returning that x is not a number. So there's no runtime type error here in this code at all. Like it's not going to crash if you pass a number or null, but JavaScript truthy checks are maybe a little bit confusing. So when we just check the condition x, that means x is truthy. So things that are truthy include, like things like one, non-empty strings. Objects are truthy, I'm pretty sure in all cases. Functions, I think, are also always truthy. But the number 0 and the empty string are falsy, so are null and undefined. And so when we pass 0 here, it's going to fall to the else case and say x is not a number. So this isn't a soundness issue, but it's a programmer intent issue. And when errors like these popped up, people started saying, hey, Flow has all the information to tell us we're doing something wrong. Can you help us out here? So we started adding lints to catch not runtime errors, but programmer intent issues. And we packaged them in a collection that you can define in your configuration file called strict. So if you put strict at the top of your file, then you get a whole bunch of extra checks that you don't get normally. So this error says that it's a sketchy null check on a number, which could potentially be 0. Perhaps you meant to check for null or undefined, which indeed that's exactly the programmer issue here. So if we just add, yeah.
Oh, Jordan, can you explain to people what you mean by truthy and falsy?
Yeah, so it's a JavaScript specific thing. So I don't know how to explain the concept. I just know what inhabits these conditions. So truthy things are not the empty string, not 0, not false, not null, not undefined. And there's probably more things that fall into the category of falsy, but it's like a rule of thumb is if it's the 0 element of the type, it's probably falsy. I don't know if the empty array, for example, is truthy or falsy. I think it's truthy. We can test it out. But yeah, so it's weird. I don't know that there's actually a real principle that guides what is truthy and what is falsy. And so that's why truthy checks are kind of sketchy. And you're more often than not trying to check if something's not equal to null, which also doesn't mean not equal to null. It means not equal to null or undefined. It's because JavaScript is the best. If you want to do not equals null, it would be not double equals null, and then undefined would pass through to the then branch of the if statement. Okay, so but back to the scaling thing now. So the way that Flow type checks this kind of code base that only has input positions annotated was it would first parse the entire code base, build a dependency graph of the entire code base, and then check the files in dependency order, parallelize as much as it possibly can, but limited by the DAG that it creates. And I say DAG because we merge cycles of files into one large file, you could say. And so the dependency graph always looks like a DAG. And so when that's how you limit your parallelization, eventually the code base is going to get big enough and deep enough that you're not going to be able to parallelize as much and people are going to be waiting a long time. So there's a couple things that we added. One of those is lazy modes, but I'll get into the lazy modes later. I want to go into the thing that changed how people code, which is we had a different idea. What if instead of having to check all the files in dependency order, we required enough annotations at the module boundary that you could very, very inexpensively just look at a file, extract the exports for the entire code base and then check every single file completely in parallel. And so in order for that to happen, you have to start also adding annotations at output positions. So here we would return a string. And so let me update to a version that actually uses that architecture. So if I just get rid of this, run flow. Yeah, so it's going to say we're missing an annotation on the function return. Please add that annotation. And when we add that annotation, the error will go away. And so this architecture allows us to, so for like very inexpensively, compared to like type checking a file, we just extract syntactically the signature of the file. And then with all the signatures in hand, which is what I think what that question was getting at before about like, don't you use, or TypeScript uses local type inference, so can't it check very fast? Yes, if you have all the signatures, you can check everything really fast and fully in parallel. And so, you know, like like Google's JavaScript project doesn't have to, or Google's TypeScript project basically has this phase as part of their build system, where they have the module signatures for these libraries ready to go so that things that depend on other libraries can connect to each other. But we build it every single time you run flow. We build the entire, like when you start flow, we build those artifacts for every single file and then check everything completely in parallel. And so that also changed how code looks. So now for all exported values, you have to have annotations on both the input and output positions. So let's go to lazy modes, because that was a huge win for a long time and was actually, without lazy mode, we still would actually not be able to run reasonably on Facebook's code base. So the intuition behind lazy modes is that for the most part, most people don't need to check the entire code base every single time they're updating a React component, because your changes to that React component don't actually affect the entire code base. So why load the entire code base into memory, or the signatures of the entire code base into memory, and then check every single file when you're really only changing like maybe something that doesn't even affect the exports of the module you're working on. So it would be a waste to do all that checking. So lazy mode only checks files that you are working on, or that I think it's that are dependents or dependencies, depending on how you define it. I think it's the files that are downstream of you, so the files that import you. Yeah, so it will only check those, and it checks those to make sure that, you know, any changes you make to the signature still propagate validly throughout the rest of the code base, anything that it affects. So here, for this example, I have a 5-file code base, but I made them all really bad. So I'll show you what they look like. I have a huge union, and then I intentionally add things to de-optimize the internal representation. And then I have an implicit instantiation and a object to basically everything I can do to take this, what could be a like relatively highly optimized representation of a union, and turn it into something that Flow is going to have to do like 10,000 squared checks on. I think it ends up actually just being 10,000, because I think another optimization does kick in. It was actually very hard to make this example. We had one of our teammates worked on these kinds of performance problems for like 3 or 4 months, maybe longer. And so I texted him, I was like, hey, I'm having trouble building an example in one file that's concise, that shows, or that can take like 1 full second to check. And he's like, okay, sounds like I did a good job then. What's your problem? So yeah, that was cool. But yeah, so that took like, I know people weren't paying attention to when it was running, but it took about 13 seconds to run. So yeah, what we start, this is what the experience was like. You'd start up a server, it would check the entire code base. You're only trying to check the file that you're working on, because you don't care about, you know, something that a team 5 orgs over is working on. It has nothing to do with your code, but you still have to wait for Flow to check the entire code base. And it's a very bad experience. So when you have lazy mode, which I'll enable in the Flow config now.
Jordan, there's a question, which is,
Yeah.
where does a 10,000 number literal show up in Facebook's code base such that it is worth having an optimized representation?
We
I'm not
actually
sure that we
have,
can talk about that much, but it sure as heck happens and at a much greater scale than just 10,000. We've
yeah,
seen
that's a good way of
some
putting it.
profoundly large unions. Like I said, I don't think we're supposed to talk much about like what the actual code base consists of, because it's Facebook, but it happens.
Yeah, it happens, and it happens. And the thing is, it provides value to the people using it. So you can't say, hey, this is unreasonable, because then they say, no, what do you mean? It's prevented all these bugs. And you're like, I guess that is our goal. So keep doing it, and we'll figure out a way to work around you.
And another question is, can you explain how only checking downstream is okay?
Yeah, so if you have the signatures of all the files that you depend on, and then you're editing a file, so that file can only change the signature of itself or files that import it that depend on its values and its own exports. So there's no way to affect the signatures of files that came before you by editing a given file, unless they're in a cycle. And if they're in a cycle, that's one file.
Now there's a follow-up question on your 10,000 thing. Is it ahead of time code generation? Is it an artifact of internal representation or some other type combinator?
It's not a type combinator. I don't know if it's code generation, but it would surprise me if it wasn't code generation. There are definitely a lot of large ones that do come from generated code, but the specific one that I have in mind that I'm sure is the one that Mike is also thinking about, I actually am not sure if it's generated or if people have just manually added a line at a time to this one giant file. And it's not the first time I've heard of something like that happening.
And one way you can do that is you can have unions of unions. So like you could imagine like if there's 10,000 files in your code base and every one of them exports a union of 10 things, but that type is like, but there's some other module that imports all of those files and merges all of those unions. That's how you can end up with something even larger than any of the individual ones, because a union of a union gets resolved to just a union. And so that lets you get very large very fast.
Yeah. And so here's the lazy mode demo. I turned on lazy mode for that project that took about 13 seconds to start up for. And with lazy mode, it just parses and it's done. So it says it's checking 0.5 files because we're not working on anything. So if I start to work on a file, so this is not with the optimized architecture. This is still using the old architecture that checked in dependency order. So if I make some change to this file to say to Flow that we're working on it, it's going to start checking every single file, which is still like most files you work on don't actually depend on the entire code base, but still checking that whole line takes a while. And so if we update to the newer architecture that does everything in parallel, even taking off lazy mode, so it'll do the entire code base. Let me run Flow. It's significantly faster. So here, I'll do a time just so we can see actual numbers for it. But yeah, so 6 seconds with the new architecture, and on the old architecture, it took, oh, and I should mention the dependency structure for these files. It's 5 files. Each one depends on the one that came before it. So it's just a chain of 5 files. And it's taking forever because of that. So it's 15 seconds versus 6.5 when you can check everything in parallel versus in dependency order. So it was a huge win. There's other things that we do for performance also. So I keep on talking about how if it changes the module signature, then you have to check the things that depend on you. So we also have these optimizations called Recheck Optimizations, where we hash the signatures of files. And we try very hard where if you have a change that doesn't change the actual signature, then we won't trigger rechecks on the files that depend on you. Because if you're not changing your signature, then nothing that imports you needs to be rechecked. I I can demo that, but I think it's a little bit harder to demo because it's skipping work. So it's probably not worth really going so far down that demo. I mean, I could pull up logs, but no one wants to look through logs to see that it says it's skipping files. So yeah, recheck optimizations are really cool. There's actually really interesting challenges with recheck optimizations also, because like white space changes are not significant to the module signature, but they are significant to error positioning. And so there's a big project to replace our representation of locations inside Flow with a more abstract representation so that they can be swapped even when the file itself wasn't rechecked. And so that error messages would render correctly even if you added white space that didn't change the module signature. So yeah, it was like a really cool project.
Wow. I think we have probably time to dig into one more topic at depth. So two candidates are the gradualness of Flow and the local type checking. And so maybe we can put out a survey to the audience. And are there other candidates that Hung-Yi or Mike or Jordan think should be in there?
The local type inference is probably the most interesting one. Yeah, I mean, that's like it's work that's happening right now. So it's like really cool if you guys want to hear about that one.
Well, Ben just gave a vote for local inference. And so cool. And then you also got some responses of that's awesome, interesting, that's super cool. And then I think you've convinced the audience to vote for local inference.
3 votes for local
cool.
inference and no other votes. So
before I hand it back off to Mike, because Mike is more well equipped to speak about the actual local inference work than I am. But now our code base looks like this, right? We no longer have completely untyped JavaScript. Our code base has evolved because, due to Flow's performance and things that engineers want, there's a lot more annotations than there were going in. And so we have this global inference algorithm that is producing bad error messages and has some confusing behavior every now and then because, global inference algorithms, that's just what they do, unless you have a lot of annotations, basically. Back and saying, given a mostly typed code base instead of a mostly untyped code base, how can we improve our inference algorithm so that our users get more predictable results? And so following that line, the obvious thing to do is to start looking at different inference algorithms. And the one that is widely used right now and very successful in TypeScript is the local type inference algorithm described in Pierce's 2000 paper. And so our current ongoing project is figuring out how we can migrate our code base to have all those. There's still more annotation requirements than just module boundaries for local type inference. So we're working on that, what the annotation requirements are going to be. And also just, you're swapping out the inference algorithm and the type checker. It's a pretty big deal. So it's a very exciting line of work.
Yeah, and I think this, just to add on to that, I think the fact that we have this really powerful type inference system that really didn't require annotations except at module boundaries that was extremely important for what Flow was when Flow came out and what Flow has been for a long time. But as we've required more annotations in order to deal with working across module boundaries and also more annotations in order to drive down the amount of completely untyped code in the code base, which I don't want to forget the person who asked about coverage, but that's been another thing that we've succeeded in trying to do. Another way we've tried to change Facebook's code base by sort of explicitly giving a measure of how much dynamically typed code there is in your program, how much is not known by the type system, how much has the any type or the bottom type or other things that behave poorly. So Flow lets you write those, but we give a metric, the coverage metric, that says 90% of your code is typed, but 10% isn't. And teams within Facebook will actually goal on that as a metric, and they'll recognize that as a way that we want of improving the stability of the code base, improving its behavior. And so using that, we've managed to drive the overall type coverage down to over 90% of the code being actually typed and less than 10% being dynamically typed stuff that Flow can't say anything about. So that's kind of how Flow has on the gradual typing side of things, that's how Flow has dealt with the fact that Flow doesn't have any kind of runtime checking because the types are erased. So instead of having runtime checking like a traditional gradually typed system would, like I'm sure Jeremy talked about when he was on here, we don't do that, but instead we try and reduce the number of sources of dynamicness and get to be as fully statically typed as possible. So because we've been successful at that, not perfectly, and there's still ongoing work in making that better, but because we've been successful at that, there's so much of the code base that's really typed that it's not, our users aren't really getting much value from the fact that we have this really powerful inference system, and they're starting to see the downsides of it. And so I'll show an example of like one of the ways that our type system, that the power of the type system can be confusing. So here's a little Flow program. We have the function f that returns 42, no big deal. And we have an object that that has two properties that we'll start off with. And one of them is going to start off as being 42, and the other of them will start off as being the result of calling f, which is also 42. Okay, fine. But it's weird that when we try and write things to A and to B, we try to write the string to that, we get completely different behavior in one case versus the other. So when we try to write a string to object.a, we get an error saying the string is incompatible with number. And the fact that we've said that 42 is the type for A is constraining the type of A to be number. But because of the internal representation of type variables that we use to actually solve the constraints in the program to figure out what type an unannotated thing has, and because we don't have an annotated return type on F, the type that Flow figures out for B isn't number, it's a type variable, an open type variable with number as one of its lower bounds. And if we write hello world to that type variable, that just becomes another lower bound. So we end up kind of inferring that object.b is actually a union of number and string instead of it just being a number and getting an error. So this is a kind of simplified example, but these issues come up quite a bit in our experience in like the things that people come to us saying, Flow isn't doing what I expect, and we have to say, yeah, I know, it sucks. So what we're moving towards in the future, and like what this year's sort of big project is ultimately is really changing the core of the inference systems to, instead of computing lower and upper bounds on type variables that can grow and get new constraints in arbitrary order, we're switching to something that's much more local, that requires more annotations, but that is going to behave much more reliably. And unfortunately, I don't think we have a great demo of what that looks like because that's in progress. But it's actually, I think Flow, it's the same basic approach that TypeScript uses for its inference. And so this is kind of an interesting way of, I think Flow and TypeScript are converging in some ways. I think there's some interesting philosophical differences that aren't going away, but in terms of like, what is Flow, what's it trying to do, it's becoming more like the direction that TypeScript has evolved. It's no longer a type system for regular JavaScript. It's starting to become a language in and of itself with its own features and its own requirements.
Well, thanks, Mike. And this is related to another set of questions I had, which was about rolling Flow out to across Facebook, because it sounds like most Facebook JavaScript code is Flowified now. And so what was that like? Have there been measures of how effective it's been in preventing bugs? How have the people taken it?
Yeah, I think, well, to address an elephant, we can't talk about if there are studies showing that it's better or not, but certainly we're continuing to have people investing in Flow, and I think there's generally a belief that it's benefiting the code base. There's a little bit of ancient history here, in that I think there was some resistance early on to using Flow. And I think it's, it's understandable, because as Flow started to add more requirements for how your JavaScript code can be written and start to become not JavaScript, it's frustrating if you have a cool technique that Flow doesn't understand, and that instead of you getting to say Flow is wrong, we're saying you just don't get to do that anymore. But especially, at this point, people have been really excited about the new reliability that this project is hopefully going to give to people. And I think I was actually a little surprised at how little resistance there was to the idea of adding new requirements for annotations. I think people were really generally on board with that.
And to touch on the rollout part of the question, we weren't there for the initial rollout, but for example, moving to the architecture that requires annotations on the output positions of module boundaries, we were there for. That was actually really early in our, after we joined Facebook, and it was a huge push. There was a bunch of us for, I think, a month or more than a month, who full-time, we were just running code mods, trying to get Flow to have, or get the code base to have fully annotated exports. My specific role in that code modding effort was I was handling the files that the code mod couldn't figure out. And so I would go and manually look at a file, be like, what is this trying to do? Like read product code, try and figure out what it was doing, then come up with a reasonable type that was like still safe, because we didn't want to like start putting any in like really critical code. So for a lot of those cases, we went in and manually typed it, and it was tough. Like it was definitely a grueling experience, but it was so worth it, because afterwards, everyone was so excited about Flow performance. Like we actually, since then, we haven't gotten complaints about performance on the whole code base, but there are some files that still check slowly because they have weird patterns, but for the most part, everyone's very happy with performance, which is great for us.
Yeah, that's awesome. And I feel like the place where I learned that if you build a tool, you have to be willing to port other people's stuff to use the tool was Facebook, because I was on a team when I was at Facebook that had spent like years rewriting PHP code into the form that the tool could consume. So yeah, that's cool that you're already done. It didn't take years. Yeah,
I mean, there's going to be a part 2 for the local type inference annotation requirements, and we've all accepted the fact that we're going to be code modding again someday soon.
Yeah,
but I think the payoff will be worth it again at the end. I mean, we wouldn't be doing it if it wasn't important.
Yeah, that's cool. Someone said what Jordan's talking about is one of their favorite parts of upgrading a compiler.
That's the kind of people we need. We need more people like that enjoy that kind of thing. So. And
then somebody else said, mark it any and move on.
That was a very strong temptation sometimes when we were doing this, when we had spent a long time trying to figure out what the type was. And I'm not going to say it never happened, but I think we did a good job of avoiding it.
Yeah, but also like suppose you're like working on ads code and you don't want one day to be pulled into a review because some ads product crashed and lost like a lot of money, and be like, hey, like why did this happen? Oh, because Jordan put an any here, and so we had no idea what this value was. I didn't want to be in that position, so I tried very hard to put very safe types.
Yeah, this is the kind of ownership that we all want to see. Cool. So there's been a little bit of discussion in the chat about how the philosophical and non-philosophical differences between Flow and TypeScript seem to be eroding. So what are the remaining differences, or are you just going to converge?
And also to add to that, I'm curious, like what do you feel like the future direction of Flow is going to be given some of these similarities?
I think one of the big philosophical differences that Flow I think is going to stick with, and my understanding is that TypeScript is going to be sticking with their behavior as well, is that I think one of Flow's really core priorities is soundness, and that's partially a response to the scaling of the Facebook code base. It's such a gigantic code base, it's impossible for anybody to have anything, to have a full understanding of any piece of code. And because it's such an interconnected code base, like you could be using things from completely different teams that you don't understand at all. And so we make some explicit decisions that to raise more errors than TypeScript does in things that are potentially unsafe, even if they're unlikely to be unsafe, because we can construct ways that they would be problematic. So an example of that is the way that array variance and variance in a few other ways happens in is modeled in TypeScript versus Flow. So like in this example, if we have an array that we've annotated as being an array of numbers called sum numbers, and we try and assign that to an array containing both numbers and strings, Flow is going to give you an error here. Flow is going to say that an array containing numbers is not compatible with an array containing numbers and strings. And the reason for that is that if we have this number and string alias, we can write a string to it and end up having a string masquerading as a number. And so if I run this program, like when this executes, oh crap, oh, we'll forget about it. When this executes, we get hello world is a number, right? And so Flow will detect this as an error and say, you're not allowed to do that. Whereas TypeScript is not going to treat that as an error. It's going to allow that variance where you can go from an array of numbers to an array of numbers and strings. And I think, again, I don't want to speak for like TypeScript developers, but I think TypeScript kind of explicitly does not promise to try and to try to be provably sound. It doesn't prioritize soundness over everything, and neither does Flow. But I think there's a philosophical difference in like the priority that we're willing to give soundness. When Flow is unsound, especially if Flow is unsound in ways that don't involve opting out of soundness by using the anytype, we regard that as a bug. And those cases do exist, but they're bugs. And I think TypeScript is trying not to get in the programmer's way, and sometimes that means allowing things that are unsafe. So that's a really core philosophical difference that I think is probably going to stay on both sides.
Another big one is like tight integration with React and potentially other widespread Facebook libraries. If it's used everywhere at Facebook and it can't be typed well, we have to support it. Like 40% of my job by days of the week is working on React support and making sure that we keep up with their future plans and all of that. Yeah, if anyone's a fan of the React server components work that's being talked about right now all over Twitter, I'm like every week working on that problem, figuring out how we're going to support it.
Well, yeah, thanks for the great answers. That's really clarifying. Cool. So we are at the end of time. And so there are many other questions, including someone wants to know if, would you use OCaml if you could choose all over again? But we cannot answer them right now. We have to answer them in the Discord. So we will, someone will post a link for the Discord. Here, I have the link, I'll post it. So Jordan and Mike will be in the Discord to answer questions. I don't know how long they can stick around immediately after this, but at some point they'll answer your questions, if not now. And so, yeah, someone said the end of time. It is the end of time. These are 1 hour sessions. And so it is not the end of all time, but the end of flow time on PL Talk today. So thank you, Jordan and Mike. And okay. So one last thing, people are always asking if I want a job working on this stuff, how do I do that? And what kind of skills do I need? And I'm sure you're also, occasionally you're always looking to hire certain kinds of people. So we can end on that.
People who are interested in type systems and working on these like very large scale problems in type systems and improving developers experience with coding are always like we're always super interested in that. There's a lot of teams at Facebook who are in the kind of broader PL space that are hiring. So definitely apply, definitely reach out to me and Jordan to chat about it. But I think it's definitely something that we want.
Yeah, but you also don't need to be like a strong programming languages person to work on a programming language team, because there are other, like half the point of using a type system these days is the IDE experience also. So if you're interested in working on the IDE experience, there's definitely room for you. And if you're also, like we mentioned that there's a lot of code mods we have to perform to upgrade Flow. It's not just for these big architectural changes. There's also sometimes just patterns we want to get rid of, or smaller changes that we need to upgrade the code base in order to handle. So if you're interested in maintaining code base health, that there's also plenty of opportunities for that at Facebook. Plenty of opportunities for maintaining code base health.
Awesome. And Hong-Yi, as the as the non-PL person who's now seen 2 type checking for JavaScript streams, do you have final thoughts for everybody?
No, I mean, I think you all covered it pretty well. I especially found the discussion about the philosophical differences pretty interesting. So yeah, thank you for that.
Cool. So yeah, we have much suspense. We need to know if Jordan and Mike prefer OCaml or another language. They'll have to answer that in the Discord. So please meet us over there. And yeah, next week we have Thomas Petrusek. I don't know that I'm pronouncing his name properly, but I'm a big fan of his ever since he worked a lot on F# as a PhD student with working with Don Syme and some other people. So next week he's going to come on to talk about philosophy of programming. And I think he has like a Commodore 64 simulator that he might demo. So this is going to be an interesting one. And then later this month we have Ned Williamson, who is not a PL person, but he uses a lot of fuzzing, and I think he has a great way of talking about his process. He's done a few big exploits that people might know about. So yeah, I think it'll be an interesting time. And then Hong-Yi and I have also been hard at work finding other people for this PL Talk live stream, which keeps going on. It'll keep going on until it stops going on. Cool. Yeah. And so someone asked which stream on the Discord. It's stream of the week. So if you have questions, please ask them there. We'll meet you over there.
Thanks for having us, Gene. This was a lot of fun.
Thank you so much. This was really, really cool to talk about. Really nice to meet you guys.
Yeah. Thank you so much, Jordan and Mike, for coming. And
Thank you for coming.
Oh yeah.
Yeah,
also thank you, Hong-Yi. This is co-hosted, and we should thank both.
No worries. All right, thanks. Yeah.
Goodbye, everybody.
Bye, guys.
Sex, money, murder, DNA.